So what we're trying to before we get into intros, just want to say a little bit about what we're attempting to do here. Um, Usually webinars are very structured. Every person has kind of their own little section and their own talking points. And we thought we'd try to do something a little differently this time. We just have a high level topic and we just talk about it, try to get some engagement from the audience. There should be a chat thing that you can see when you're logged in right now, and just kind of see where the conversation goes and see what information we can share and even what we can learn from each other and generally from the audience. So this is a little bit of an experiment. Please bear with us if there's any rough patches or it doesn't work quite the way that we thought it would. But grab a coffee, a beer, or your drink of choice, and hopefully we can all learn a little something here. So what we're going to do is the high-level topic we've chosen to talk about is just access points in general. Kind of a bit of a war story situation on the good, the bad, and the ugly. I'm not sure which one of us here is meant to be the good, the bad, or the ugly. But we'll just kind of do a quick little roundtable of intros, and then we can just kind of dive in and see where things go. So I'll kick it off. My name's Dan Siemon with Preseem. I've worked with internet providers basically my entire career. I owned a small internet provider. I worked as a network manager, worked at a larger vendor dealing with really big internet providers, and then of course now with Preseem. So I have managed fixed wireless networks, but that's been a little bit in the past. So I'm not going to be the guy to talk to you a lot about how to tweak an individual current access point model. I think Brandon and Jeremy can do a better job of that. But we do see tens of thousands of access points on hundreds of thousands of subscribers, and we collect a lot of data. So on an aggregate view of how these models perform, I think we have some useful information, and hopefully I'll be able to add that to the conversation. So with that, Jeremy, Brandon, if you guys want to introduce yourself, and then we'll just go from there.
Hi, my name is Jeremy Davis. I'm a consultant with Wisp.net. I have been working in the wireless industry for about 20 years now, in many different facets, from being a system administrator to being an executive. So looking forward to being able to share some knowledge with you guys today.
My name is Brandon Yarbrough. I'm one of the onboarding specialists with Wisp.net. I also have a few Wisps that I'm consulting with currently, and have owned my own Wisp in the past as well that I created out of necessity. I think is how most Wisps start. They see an opportunity for internet that's underserved in their community, and they try and build it up, and that's exactly what I've done. So that's kind of my experience and where we're at today.
Cool. That's kind of how I got into this mess too. I grew up on a farm as well, didn't have great internet, so I ended up starting a dial-up ISP so I would have internet. So yeah, it's probably a pretty common path. Cool. So we have some discussion ideas here. And again, this isn't really meant to be an agenda. We're not going to try to pick these off one by one or anything like that. We just wanted to have a few things that we can kind of steer the conversation around as we go. And when we were brainstorming these, one of the things that came up a bunch of times was the idea that oftentimes people run their access points overloaded, or as I called it here, too hot. And this ends up having a lot of downstream negative impacts on subscribers and just network in general. So we thought maybe we'd start there. And a little way of kind of motivating that, I just want to this is the only prop we have in the whole presentation, is a little bit of data to kind of motivate how I think this happens. So this data comes from our fixed wireless report, where we aggregate the stats across all of our customers and kind of give a picture of how individual access points perform. And I'm going to pick on the one on the leftmost here, not to be mean to Ubiquity. It just is the first one, so I'm going to pick on that one. I went to look at the website the other day, and the Rocket Prism 5 AC, they actually have 500 megabits per second listed in the little caption beside that AP. But when we look at thousands of instances of that across all of our customers, 95% of them deliver less than 60 megabits per second across all their customers, all the subscribers. And I think I'm sure the 500 megabits is real. Like, I'm sure there's some situation where the AP can do that. But the reality, when you have a lot of subscribers, appears to be very, very different. And I think this is one way that people get into a situation of thinking they can put a lot more on an AP than they maybe can. And that kind of ends up with all the negative things that we'll talk about as we go forward. So with that, Jeremy, Brandon, jump in and what's your experience with overloaded access points or
So I think a lot of those real world statistics versus what you're actually getting are, again, in a lab and controlled environment versus what's actually out there and the interference and the noise floors that we're seeing out there today versus point to multi-point systems or point to point systems. Is that radio capable of doing 500 plus megabits per second? Sure, in a controlled environment. Are you going to see that in wild? No, probably not.
Mm-hmm. Absolutely. And it dramatically changes based on the amount of customers that are connected to the access point. I've seen some amazing tests on even just older microtik gear with one client. At that point in time, the scheduler is not degraded, and you can do all sorts of crazy speed tests. But as you add more customers, you're going to see the overall throughput decline for the access point.
Yeah. And that gets all the way down when we start talking about TDD timing and how many clients you have on it, the less service you're going to be able to provide to each customer.
Yeah. Can one of you guys, so I mean, that low level radio stuff's not my thing. So can you guys, one of you talk a little bit about like why many customers on an AP degrade support performance? Like if it can do 500 with one subscriber, why can't it do 100 to 5 subscribers?
Well, it's kind of like the analogy that I always use is like a herd of animals can only move as fast as the slowest animal. So when you're talking about an increase in customers, it can change depending on what their conditions are. You know, I've seen access points where all the customers were within a mile, all had great modulation, and you see a tremendous performance. But even as many as 1 or 2 customers that have bad signals will degrade the entire scheduler. When you're thinking about a schedule and thinking of it like as pieces of pie, you know, the pie can only is symmetrical, and it can only be as efficient as the worst piece of the pie, essentially. So when you have that one customer that's pushing that 10 miles, you know, shot that maybe you could get a marginal speed test, you know, you're probably actually in reality denying 2 or 3 other people access to that access point before it hits capacity. So that's kind of like a very simple way to describe why that works that way.
Yeah, that's a great analogy, Jeremy, as far as the piece of the pie puzzle there. You know, especially if you're talking about buy cells in the LTE system, you get 1 or 2 people with a really bad SINR or bad signal, it really can wreak havoc on the entire access point.
And the thing we're talking about there with the pie is I kind of think of that as like airtime, right? Like you're dividing up how much time the access point, the pie is like the slices to each subscriber. And if you have a lower modulation, that person's going to take a bigger chunk of the pie. That's kind of what you're saying?
Yeah, exactly. And once again, it's very interesting how different vendors can handle it, because you'll see some vendors where one bad signal will tank the throughput for the entire access point, and you'll see some of the proprietary methods of connecting to an access point where it's just very different. In some of my experiences, that the Cambium products actually handle a couple bad users a little bit better than, let's say, a microtik, would be a good example. And that's just due to the proprietary algorithms that are used to actually connect to customers.
Yeah, that makes a lot of sense.
Yeah, what would be your definition of a bad customer? Like, are we talking about like certain SNR, or like what would you just if you had to look at one to tell people on the call, like one number to look at, what would that be, or what would be the threshold for good and bad?
Well,
or does it exist?
That's a very good question. Really, what it boils down to is modulation rates. I think that's the be all end all. The modulation rates are inherently based on your SNR, so that is a thing as well. But you'll have situations where you have a decent SNR and a bad modulation. It could be like some localized interference that's not being picked up by the access point. There's a few things there. So at the end of the day, I honestly feel that, like, from a CPE standpoint, your modulation of your connection is the most important thing to look at when determining the quality of the link. And it would also be consistency. If you just look at the access, or look at the client once and it does well, that might not be an intermittent issue. Maybe it drops out in 5 minutes, so you'll see some maybe extended test scenarios where you need to do that to get the real life story of what's going on with the customer.
Yeah. And fixing bad modulation or bad SNR rates does not mean, hey, just turn the power up on the access point a little bit so that person's get better signal, right?
Doesn't?
That definitely does not mean that's not the fix.
So what is the usual fix? What have you guys had to do to deal with this? Is it split
Typically,
to a different AP or?
Yeah, you can either split that person off that you're trying to get onto a specific access point that doesn't have great signal. You can either put them on a different access point, or they need a different CPE. They need something with higher gain that can push and pull the packets a little bit farther than what they've currently got.
You know, and sometimes that can be fixed by putting a higher gain antenna on the CPE as well. Sometimes you'll see some obvious shots where you don't think that you need a bigger antenna, but in reality, a bigger antenna does increase the SNR, which increases the modulation. Another thing, you know, is to be able to manage the traffic shifts of the access points. You know, sometimes you'll have an access point that has a lot of customers, and you can kind of move those customers around to be able to equilibrize the actual throughput that's going through multiple access points. And one other thing to note is sometimes if the install was done when there was no leaves or anything on the trees, it might even just be as simple as mounting the CPE on the other side of the house. You know, a lot of times with the low-hanging fruit, you're going to, you know, an installer will want to install it in the easiest place possible, but that will not always be the most optimal place on the house to install.
Absolutely. Jeff looks like he asked a question here in the chat. He asked if he could scale his thinking down to wireless access points inside of a building, such as a Cambium or Ubiquiti access point for client access. And quick and easy answer is yes.
Yeah, I think a lot of the same concepts generally apply, right? Even your home Wi-Fi. Like if you have one TV on the far side of the house, it really does hurt everything.
Yes.
Streaming, of course. Yeah.
Absolutely.
Yeah. So what's your nightmare story of having to deal with this? Do you have a
nightmare story specifically with this, or just a nightmare?
Yeah, well, I guess overloaded APs in general. I mean, have you had some scenario that was really hard to fix or really hard to debug, or just something, anything in that area?
I think the hardest challenge that I have is educating people on reality here, because as a consultant, I get all of these people coming to us and having high expectations. They're wanting, they're seeing these numbers of 60 to 70 subscribers on a single access point with 500 plus megabits per second of throughput. And well, yeah, that's all fine and dandy. And vendors actually put that on their boxes, but are you going to be able to deliver 500 megabits per second to 60 or 70 people 30 miles away from a single access point? No.
And we've seen, kind of related to that, I mean, we've seen a bunch of situations where customers they'll reach out to us and say, hey, my end subscribers aren't getting the speeds test they expect. And because we have a lot of data, we actually know, like those things I showed you before of what an AP should be capable of, and it'll turn out to be something. I'm just making up numbers to make it easy. They'll be like, well, I have a 30 meg plan on Bob, and we look at the AP model he's using at best does 20 meg on like in a really good deployment, and it's very shocking to people. They don't really understand that they've kind of made that mistake.
Yeah.
You know, another thing I see is that there's always people are, how much bandwidth can I get out of this access point? What's the max that'll push? But in reality, pushing the max bandwidth on an access point will actually give you higher latencies. So, you know, it's not a matter of like how much can we get through it? How much can we get through it while still maintaining a proper latency measurement with the customers? And those are two very different things. I found in a lot of ways that finding what your AP will do, and then, you know, pulling it back maybe 5 to 7 megs from what its, you know, maximum throughput in its current condition is, will actually give customers better service. And you find that, you know, sure, maybe you're slowing it down and customers might not get their speed tests, but in the reality, we all have those customers, but most customers only speed test when they're having problems. So if you cap that, you know, down just a little bit and you don't have problems, well, they're not going to call.
Well, and a lot of things. So this is something we spend a lot of time on as well. Is a lot of performance of how you feel the internet is really comes down to latency, and it really is not throughput. Like if you're web browsing, you need those DNS requests to get out fast. You need the beginning of the web page to come in fast. Raw throughput often doesn't figure into it as nearly as much as you might think. I mean, if you're doing a giant download, that's a different beast. And this gets back to all the buffer bloat stuff, right? Like any device that's moving packets, if it gets behind, it starts buffering the packets, and generally the quality of experience goes to crap as soon as that happens. So like what you were saying, just keeping the bandwidth below that cliff where everything gets really nasty really does make a huge difference. And that's not even just a wireless thing. That's kind of a general packet network thing.
Absolutely.
Yeah. Cool. So what else? Where else do you guys want to go with this? Let's have a good Cambium or Ubiquity war story.
Oh,
Yeah, I've got a good one. Wow, we had the weirdest problem in the world. I want to say maybe it's 6 months ago when I was working at a wireless ISP, and somebody had not enabled client isolation on the access point, and a customer rewired their desk and flipped the interfaces. And without client isolation going on, you're going to randomly have people dropping and popping off the network. You're not going to be able to ping anybody because your gateway is now on a customer's router. And it was the weirdest thing when the phone text came to me. It was like, he's online for like 5 seconds, but we can't log into his radio. And I'm just like, that's the bizarrest, like thing I've ever heard of. And it turned out that the access point didn't have client isolation on, which then broke it when they plugged in the router backwards. But that was not a fun one to troubleshoot. It was kind of one of those that we wrote down in the playbook for future reference. But the initial finding that problem was pretty tough.
And did you guys have like a checklist for this should have been turned on and it was just kind of missed in deployment of that access point?
Yeah, we had standardized configurations, but anytime a human's clicking a mouse button, there's a chance for failure. Despite all the quality control efforts we had in place, this one slipped by. And then interesting enough, it happened about 2 months later. And then it was like a 2-minute troubleshoot. It was like, oh, we've seen this before.
Nice.
Learn from experience.
Yeah, and sure. Enabling client isolation should just be a default setting for the access points when they're in access point mode.
Mm-hmm. And is that just in both Cambium and Ubiquity? That's just like a checkbox defaults to off.
It is, but the default is off. Yeah.
Yeah.
Maybe because there's some people that are using it for LANs and things like that, or maybe like a smaller wide area network or a campus where the computers need to be connected. Maybe there was a good reason, but you would think that a set of default settings should be a good working default, and not like leaving you open to something like this.
Yeah. So what that's actually doing then is like blocking broadcasts from traveling back, like up a subscriber and down to another one.
Yeah, that's correct. The broadcast to domain traffic.
Yeah, cool. Yeah, those things can be tons of fun. Even in an office LAN, you get the guy that plugs in the D-Link just for fun, and all of a sudden it's handing out IP addresses. Those aren't a whole lot of fun to find either.
They really are not. I mean, that's like layer 2 troubleshooting can be rather difficult in a lot of situations. You don't have a trace route or a ping. You can kind of look at ARC tables and things like that, but definitely layer 2 issues are way more difficult to troubleshoot than layer 3.
And the thing that you hinted at earlier, like that's usually how they manifest too, is like intermittent. Like it works for a few seconds and then it doesn't work. And then it works. That kind of is like, to me, is always like the hint that this is a layer 2 problem. That there's like STPs flipping between ports or something like that. Like it's just kind of, it's a good pointer, I think, for this is likely going to be a layer 2 problem.
Absolutely.
Cool. So what else? What's your favorite access point?
I've been deploying a lot of the LTU stuff the last couple of months, and
cool. Talk about that. I don't think there's probably a lot of people that haven't.
So it's basically Ubiquity's custom chipset. So they've basically taken their AirFiber chipset and made it a point-to-multipoint type deployment, which is a custom chipset instead of using a traditional Airthos laptop chipset, which is beefed up. That's the short and nasty version of it, but there's some other underlying things going on behind it. EPMP 3000 has been going pretty well. I've been trying to get my hands on a Medusa, but haven't gotten there yet.
And the LTU stuff's been working well for you?
Yeah, in the couple of deployments that I've done it, I mean, haven't been super large deployments. They've been like four stations to a single access point, and I'm seeing 250, 300 megs flow through it on a 40 megahertz channel, and it's going really well.
Yeah, cool.
So, very good. Well, you kind of alluded to mine. Mine's the 450. I've got the opportunity to deploy quite a few of those guys in my last job, and just what an amazing platform. I mean, once again, it's it's a tool in the tool chest. It's not necessarily the be all end all. I mean, if you don't have the density, then it's in a very expensive product, and a 2000 or a 3000 would best serve you. But as far as managing your radio frequencies, being able to do the aggregation of bandwidth and customers through a 450 is just amazing from an RF planning network. Previous to those devices, we would have sometimes, 8, Cambium access points, working with some down tilt, maybe some DFS frequencies, using horns, things like that to clean up your RF environment. But that's at some point in time that becomes unruly, and having something like a 450 is super clutch. And even going back to, if you want to do some LTE like deployments, the 450 that works in 3 gigahertz is a really amazing platform as well when you're talking about non-line of sight and things like that. So as you can tell, I'm a huge advocate of the Cambium platform and about any product that it has currently available.
Yeah. So that brings up another, you just mentioned horns. I mean, how much has life gotten better since the invention of horns?
Well, it's an interesting thing because when you go to use a horn to replace an existing sector, you almost get like a split bit of headache because that horn is not propagating sloppily like a lot of the other sectors do. So you've got these customers that are connected to these side lobes that now no longer can connect, but it's a short-term sacrifice for a long-term gain because your customers in general will be working better long-term.
Absolutely.
So have you guys used horn antennas with like both Ubiquiti and Cambium, or how? Again, I'm far from an antenna person. So when did that start, and what hasn't worked with that?
I mean, the horns, I started with, the RF element horn antennas on some old 5 gigahertz M5 stuff before the AC gear was even around, and just moving away from, the Ubiquiti sectors into a horn was a huge improvement. You might have lost a little gain going from one of their taller sector antennas to a 60 or 30 degree horn antenna, but the increase of or decrease in spectrum noise was more than enough to make up for that.
Absolutely. I've seen that at many ISPs where I collect statistics and things like that. The implement of a horn is definitely something special when you're talking about probably your most valuable asset as a WISP is your spectrum. It's not guaranteed, and you got to try to use it as efficiently as possible and play well with others. And these antennas, like these horns, do a really good job. And it's not just for your customers, but it's also being a good neighbor if you have neighboring WISPs as well.
So it looks like we have a question there. So what's the best solution for customer rate limiting? Oh, sorry, there's two there. Let's back up one. You talked about client isolation. Isn't it? Does it block broadcast traffic, but will allow unicast traffic between users? So if you have two families on the same AP with this enabled, how do they communicate?
They would not.
Yep. That would be definitely one limitation with that setup. But then again, like providing transit's typically not the goal of providing your last mile wireless solutions. So you'll only be in very few situations. We've came across maybe a couple business situations, but then just using something internally to do a VPN from one site to the other can kind of eliminate in those one-off situations.
I guess that would be one advantage of doing something encapsulation like PPOE or something, right? Because that would just flow through the PPOE tunnel, the concentrator, and right back down, and it would just work.
Yeah, that might be the only case for advocating PPPE, to be honest.
Yeah,
At this point in time,
yeah,
there's just a lot of better mechanisms to do that these days, but that's definitely one for sure.
Yeah, cool. So what else? What's the best solution for customer rate limiting at the SM or something else? So
I'll take this one.
Yeah. Okay.
Ask Dan.
Yeah. Yeah. Fair enough. So it's just, yeah. So there's two things to kind of be a little careful here. So rate limiting at the SMs have in our experience, have very simple buffer management. So if you try to do like a 5 meg shaper on the SM, you're likely not going to have happy customers when they hit that 5 meg limit. So what we try to do is and we tell people on the upload side, you still might want to keep the shaper there as kind of like a fallback. If there's like somebody doing like a DDoS flood kind of up, or a DOS flood up the wireless connection or something, it's useful to have that as like a fallback. But generally, you really don't want the access points or the SMs to be buffering packets, because they do a pretty bad job. Like as soon as they hit a limit, the customer will be generally pretty unhappy with you. So
if you are going to do it at the SM, over provision it a little bit.
Yes, yeah, over provision, and hopefully in a perfect world have something else that's doing a slightly smarter job than the SMs will.
So either a queue on your router or something like a QoE system like Preseem doing that. So.
Now, the most optimal way, like if you were like wanting to see the perfect scenario, is that you would see downloads being rate limited more towards your core or your edge of your network, and then your customer upload being most likely a router at the tower. I mean, if you wanted to get really granular with it, that would give you the point where your bandwidth limiting is hitting closest to the source of the data transfer. But I ran some pretty in-depth statistics for probably over a year, and we very few times ever had customers max out their upload. It's just not, normal usage. I mean, sure, if you have security cameras or things like that, that's one thing. So you could almost make a case for not even rate limiting uploads, with an exception of maybe, denial of service attack or something like that is originating from your customer. That might be one thing that would stop it from traversing through your network.
Yeah, because in theory, someone doing like a big UDP flood up with no limit at all in the SM, they could consume a big chunk of that AP's bandwidth if they really wanted to be nasty.
Absolutely.
Yeah.
So okay. Nick is asking about the IgniteNet 10 gig Omni. I've deployed one of them. I don't know if Jeremy has or not. Have you?
Yes, I have. In some ways it works great, but it's definitely not what you're used to working with. I mean, you're going to be talking about having to be very close to the access point, and we're talking about the strictest line of sight that you've ever seen. Like, you've got one leaf in between, and there's a good chance that you're going to have a degradation in performance. We had a little bit of problem with their equipment, like when they first came out. But it seems like their second generation and new firmware has kind of worked out a lot of the issues we had. One of the things they do have is like a mesh system as well that can be deployed on those bigger, like 10 gig Omnis. And you can use those to like flood downtown areas and try to pick up business. But as far as it working when it worked, we had pretty good luck with it.
And what was the distances you pushed?
Less than half a mile.
Yeah, not very far at all.
So, and it also has some elevation limits. It's not really like there's not much down tilt on the Omni as well, from my experience. So you have to kind of keep that in mind when you're designing a network around one of those 10 gig Omnis. So
you're saying it's a little more designed for like stick a post up in a neighborhood and go to like 4 houses that are level?
Yes, that would be an ideal situation for that Omni.
Yeah.
Think of like a downtown area, where you have a lot of common areas and fountains and things like that. And that would work really well from a RF perspective.
Yeah.
Interesting. Any other 10 gigahertz products you guys have worked with?
That's not 10 gigahertz. It's actually a 60 gigahertz product.
Oh, sorry.
Product. Yeah. It's got a SFP port on it, and it's 3 sectors that are all 10 gig, and are capable of doing 1 gig or 8. I believe you can have 8 connections each of the sectors, and last firmware I worked with anyway. I could be wrong, but it was a good product for what it was.
I've never really worked with other multi-point solutions, but I have worked with the MikroTik wireless wire, and what a phenomenal, easy-to-use product. Pretty impressed with it. We didn't have really any problems. We don't have like torrential rain or anything like that either, but we never really had much of a problem with them cutting out at all during the weather we had in Nebraska.
So I just started doing a lot of the 60 gigahertz stuff from Ubiquiti. I've used a lot of the wireless wire stuff in the past. However, if your network is a Ubiquiti network, which there are a lot out there, I'm not going to say that they're the best. I'm not going to say that they're the worst, but there are a lot of them out there. Their monitoring solution, UNMS, has come a long ways, and the ability to have those 60 gigahertz links into UNMS has been kind of key for helping troubleshoot problems as they do arise from time to time. So,
cool. Thanks. So just to kind of close the loop on the previous discussion, yes, we do customer rate limiting at Preseem. I was trying not to be too marketing-y there. That's a big part of what we do. We measure quality of experience and then manage traffic to make it better. So. Yes, so happy to talk about that more in kind of a different context. So another question, have you seen issues with Google Mesh and hotspot MAC address authentication in MikroTik hotspots? Google Mesh, so the Google Home Wi-Fi mesh, I guess?
I don't have any experience with the Google Mesh stuff. The hotspot MAC address authentication is something that we do a lot of at VISP. It's one of the methods that we use for authentication to our radius servers. So yes, we do know a lot about that. If you have questions, feel free to contact us later about that, and we'll be happy to help.
Yeah, I have no experience with the Google Mesh products, so I don't have much to give on that one.
Mm-hmm. Yeah, it'd be interesting if that interacted in some way. You think you might have seen it by now with your number of deployments. Like, I think Google's done reasonably well at selling that mesh product.
I've seen them out there, but I've been seeing a lot more of the Orbeez out there, and
okay.
I think that's the most common one that I've seen. But I'm not a big fan of the mesh systems to begin with. I'd rather hardwire everything to a central location.
A wire. Yeah.
Even when it comes to a home, it's like, well,
yeah.
If you've got bad Wi-Fi in a room, don't put a mesh there because you're just broadcasting bad Wi-Fi to it.
Yes. Yeah, if you can put a wire somewhere, do it. If you can't, then you use the wireless. Who knows? That's for sure. Cool. So what else we want to talk about? We're kind of running up on sort of the 40-minute-ish time frame we kind of thought we'd do here. If you had to make one recommendation maybe for each vendor, Cambium and Ubiquiti, what's like the one thing you wish you knew before you started doing a bunch of deployments? With a particular model or the vendor as a whole?
With Cambium, probably I would have never bought any light versions of the access points because it makes the licensing more difficult, down the road, and it seemed to not have a lot of benefit to save that initial money up front. And then probably, waiting for the 3000s to come out instead of, we went with a lot of the 2000s, and the 3000 just had more throughput. I think it had a better noise filter in it. Making sure you don't get the light versions because I don't think the light versions have the same noise filtering or any noise filtering at all. So it's quite a bit of different beast. Maybe with the Cambium stuff, the licensing is way different than probably any other vendor. So doing some research on how you can manage your license would be something that I would have liked to have more thought into before deploying a lot of it.
Cool.
Yeah, definitely a lot of information out there, and having it a little bit better as far as their product line for Ubiquiti would have been useful. One thing I could tell anybody getting started with Ubiquiti is don't visit their forums. If you try to ask questions, you will be bombarded, and people are mean on forums. Hire a consultant, talk to someone who actually knows, and you'll be getting your foot off in the right direction.
Cool. And you'd said you've done some BioCells LTE as well.
I have.
Anything to add there?
me and Jeremy both have done some buy sells. With the CBRS stuff now coming out, it's going to be a lot more readily available for everyone who doesn't have an in license. So it's going to be creating some more noise in the environment. So I don't know how that's going to play out. Well, I guess only time will tell. I don't know, Jeremy, what's your experience with the buy sells?
You know, I thought it was a great product, but it just depends on your customer density. Basically, because you're set at a maximum amount of users per sector, that if you're looking at a small town and you're just covering like trees in people's houses or in front of houses, like you're talking about like a small rural town, but there's trees everywhere, those work great for those situations. But you know, if you're one of the only providers in the area and you have a dense cluster of customers, I would definitely recommend the 450 3 gigahertz product over it, just because you can get a higher aggregate throughput and a higher amount of customers. You know, once again, I don't like my Phillips head screwdriver any more than my straight slot screwdriver. You know, so it just depends on which tool is going to work best for me in a specific situation.
Yeah, absolutely. I've personally deployed that buy sells in just that, what you were talking about. It's a very rural community, lots of pine trees. Altitude is your friend when it comes to the buy sells access point. Get that thing up as high as you can.
Absolutely.
Cool. So maybe one more here, or we're going to run out of time. So with regards to spectrum efficiency versus client count, what are examples of how your networks operate in order to accommodate future growth?
Not sure I understood what you were asking.
I think maybe, well, let's start with like number of subscribers on some of the access points. Maybe the question is a little bit about like how do you set up a tower so you can continue to add subscribers but not end up with too many subscribers per AP? Maybe we'll start there.
That's kind of open-ended, because we kind of touched about this earlier, right? It all depends on the package rates that you're trying to pass through. So if you're trying to pass through, 100 megabyte packages, you might only get 4 or 5 clients per access point. But if you're
that's a really good place to go, and I actually meant to do that earlier. So if you had an access point that can do 50 meg, what plans would you be willing to sell on that access point, and how many?
On an access point that actually pushes 50 meg,
sure,
I'd probably be selling 15 megabyte packages.
Okay,
and I would probably be 20 max.
Okay, so yeah, Jeremy, any rules of thumb on that kind of thing? I know it varies a lot by vendor, so.
The rule of thumb is it almost varies like within the same vendor and the same access point. You know, it's like such a loaded question. I smile because like this alone can be talked about for an hour itself. You know.
Yeah.
But when it boils down to it, I think on a very minimum, you've got to at least be able to do, like say if your access point can do 100 meg, then 50 meg would be the biggest plan. And I would consider that pushing the limits. But I've seen it done. It depends on what kind of traffic you have. It depends what kind of customers you have. I've seen some rural access points where the oversubscription ratio was amazing if you could build a business model on that alone, you know. And then I've seen some in town where like 16 customers just flat smoke the throughput of it. You know, you've got 4 kids in a house all watching their iPads and doing Netflix. Like,
yeah,
that bandwidth goes quick.
Cord cutting has really put a hindrance on these access points and made a lot of these WISPs step up their game.
Yeah.
So
sure. Yeah, much more consistent throughput. Yeah. Okay, so very last one. How much actual tree penetration with CBRS? I've heard 1 mile and loss.
Completely depends on the type of tree.
So what's pine's worse, or
in the thickets that I'm out here in East Texas, I've got half a mile of non-line of sight. If I can get some elevation on the CPE, then I can go 2 miles, no problem.
All right, cool. Any thoughts, Jeremy?
You know, for the most part, in the environments that I've worked in recently, it's not dense thickets of trees we went through. It was to avoid the fact that every single person had to 1 or 2 trees in their yard type situation.
Mm.
So I don't really have a lot of experience passing through dense foliage. You know, so, you know, it was more like, you know, working my last job in Nebraska, which is where Arbor Day was founded, was the most like vicious thing to do to a wisp, because everybody has a tree planted in their yard, maybe 2 or 3, you know? So, you know, we didn't have the problem of going through, you know, mass swaths of trees, but it was more just getting that last, you know, 100 feet or so. So that's been my experience and how I've used it, and that worked really well for us.
Cool. Okay, well, we're up against the kind of 40-minute target, so I think, and I don't see any more questions, so I think maybe we'll stop it there. Everybody, if this was useful or not useful, or you think it was a silly format or a good format, let us know. I had a good time. I think I learned something. Hopefully everybody else did too. And I think with that, we'll call it an end for now.